So far we have discussed about tropospheric pollution. Now we will make the discussion related to stratosphere. The stratospheric pollution, how it occurs and how do we control it. Let us see the discussion in detail. Let's see now stratospheric pollution. Stratospheric, actually where stratosphere will begin? Troposphere ends at 10th kilometers. Stratosphere begins from 10th kilometers. That is, it will reach up to 50th kilometer, 50. So from 10th to 50th, I can say 11th to 50th is the stratosphere present in the environment and the atmosphere. The upper stratosphere consists of a considerable amount of ozone. Upper means 35th kilometer to 50th kilometer is the upper stratosphere. Bottom stratosphere from the 11th kilometer to 35th kilometer. So the upper part will be having considerable amount of the ozone gas, which protects ultraviolet, which protects the life on the earth, which protects us, I can say, from the harmful ultraviolet radiations having a wavelength of 255 nanometers coming from the sun. Directly, if ozone layer is not present, they will enter into the atmosphere and it will cause so many effects on the human beings. And the stratospheric pollution is mainly because of the entry of the ultraviolet radiations into atmosphere. The ultraviolet radiations can cause skin cancers, melanoma I can say, in human beings. Therefore, it is important to maintain the ozone layer thickness and which is protecting us as a shield. So the shield thickness can be always maintained so that the life on the environment, life on the atmosphere, life in the biosphere, I can say that 0 to 10 kilometer tropospheric life is safe because of the ozone layer present in the stratosphere. Ozone in the stratosphere is a product actually of UV radiations on the dioxygen molecules. How do you prepare the ozone in the stratosphere? Ozone of stratosphere is obtained by the dioxygen present in the stratosphere take up or absorbs energy. This energy from UV light. This is from UV light, and this absorbed energy from the ultraviolet light which is coming from the sun is converting dioxygen molecules into ozone. Formation of ozone is endothermic process. The ultraviolet radiation split apart molecular oxygen into free oxygen atoms. Dioxygen molecule into free oxygen atom. These oxygen atoms are combining to another molecular oxygen and to form as a ozone molecule. So let's see now, O2 absorbs energy and this is ultraviolet light and split up into oxygen gaseous atoms. This is O2 dioxygen gas. It is absorbing energy, split into oxygen atom single. This single oxygen atom gas reacts with the dioxygen molecule present there and it will be converted into ozone gas. It is converted into ozone gas. This ozone is thermodynamically unstable. This ozone is thermodynamically unstable and decompose into again by molecular oxygen by releasing again one more single oxygen atom. So as I've told you now, preparation of ozone in the stratosphere, it is a natural process. It is prepared by the nature, absorbing energy from the sunlight and forming into O2. This DiO2 split into single oxygen atoms and reacts with dioxygen molecules there and form ozone molecule. So produced ozone molecule is thermodynamically unstable, gets decomposed into molecular oxygen whenever it is again taking up energy. This stratospheric pollution is discussed as ozone layer depletion. Ozone layer depletion. This ozone layer depletion, the main reason for the depletion, holes in the ozone layer, is believed to be release of chlorofluorocarbons, CFCs, chlorofluorocarbons or carbon compounds, also known as freons. You can call them as freon. Freon is a common name given for chlorofluorocarbons. These compounds are non-reactive. These are non-reactive compounds. They do not even catch the fire, non-inflammable. They are not even poisonous. They are non-toxic molecules, and therefore they are used in the refrigeration system and also in the air conditioning systems. When they were discussed the first time by the scientists in the world, it was thought that it's a boon to the industry because their preparation is so easy, their preparation is so cheap, and they are very stable. So that they thought that it's a boon to the industry. Later, it was noticed that they are causing curse to the environment. So it is a curse to the environment. Later they are realized. Once chlorofluorocarbons are released into the atmosphere, they mix with the normal atmospheric gases and eventually reach to the stratosphere, that is from 11th kilometers to 50th kilometers. In the stratosphere, they get break down by powerful ultraviolet radiations, releasing a chlorine free radical. One chlorine free radical which is released in the stratosphere can damage 1 lakh ozone molecules. Already released chlorine free radicals can damage ozone molecules for another 50 years. Therefore, because of this curse to the environment, scientists worldwide banned the usage of chlorofluorocarbons because one single chlorine free radical can damage extensively 1 lakh of ozone molecules roughly. So, if you observe the reaction here, you can see, you can observe the depletion starts like this. You can observe this chlorofluorocarbons, freons, gases. By absorbing ultraviolet light, they will release chlorine, single gaseous free radical, chlorine with a dot, and CF2Cl. CF2Cl. This is again gas. This is equation 1. The chlorine radical then react with stratospheric ozone to form chlorine monoxide radicals and molecular oxygen. This is equation 1. Let's see now equation 2. This chlorine free radical combines with ozone present in the stratosphere and form ClO gas. It will form ClO, that is chlorine monoxide, and produces molecular oxygen. Let us say this is equation 2. This is equation 1 and this is equation 2. Now, reaction of chlorine monoxide radical with atomic oxygen produces more chlorine radicals now. It's a continuation now. The produced ClO, this produced ClO, chlorine monoxide radical with this also radical with one oxygen, single oxygen produces, it will produce now chlorine free radical again, and O2 gas is produced. Chlorine free radical is produced and again O2 gas is produced. See, this is equation 3. This is equation 3. So, chlorofluorocarbons are transporting agents for the continuous generating chlorine free radicals or chlorine radicals into the stratosphere and damaging the ozone layer. This is single chlorine free radical damages ozone, again form ClO, and this ClO radical combines with oxygen, single oxygen atom, and form chlorine free radical. In the step 1 we got this, again in the step 3 we got chlorine free radical. Like this the process will continue. Continuously the ozone layer present in the stratosphere being damaged by chlorine free radicals. So by this way you can observe the depletion in the ozone layer. One chlorofluorocarbon molecule, that is release one chlorine from it, destroys 1 lakh ozone molecules roughly. That is what occurs to the environment. One chlorofluorocarbon molecule destroy 1 lakh ozone molecules. That is what occurs to the environment because of the extensive usage of chlorofluorocarbons in the refrigeration process and as well as in the air conditioning units. This is the damage. Because of this, directly the thickness of ozone layer becomes less, and you can observe the holes in the ozone layer. Because of the holes in the ozone layer, you can see the following effects. Now, with the depletion of ozone layer, more ultraviolet radiations filters into the troposphere from the stratosphere. That is, directly UV radiations fall into the 0 to 10 kilometers. So these UV radiations lead to aging of the skin. Skin becomes aged, cataract in the eyes, sunburns, skin cancers, killing of the many phytoplanktons, damage to the fish production, damage in the fish production, etc. are the considerable, noticeable, observable damages are because of the chlorofluorocarbons, because of the ozone layer depletion. It has also been reported that plant protein get easily affected by ultraviolet radiations, which lead to harmful mutations of the cells. These are all because of the chlorofluorocarbons directly causing ozone layer depletion, releasing UV radiations. UV radiations causes all these effects. And some more effects of ozone layer depletion we can also observe like this. It also increases the evaporation of the surface water through the stomata of the leaves and decreases the moisture content of the soil. By this way you can see more warm in the particularly in the sunny season, in the summer season. Increase in UV radiations damages the plants and fibers, causing them to the faster, and like this you can understand the ozone layer depletion. If at all a question comes like this, which one of the following is mainly responsible for the depletion of the ozone layer? If the question comes like this, you can go for options: methane, carbon dioxide, water vapor, chlorofluorocarbons. So obviously we can go for answer as chlorofluorocarbons. That is the main cause or main responsible for the depletion of the ozone layer. And another question can be possible: cataract and skin cancers are because of options: depletion of NO, depletion of ozone layer, increase in methane concentrations, depletion of nitrous oxide. So obviously you can go for answer as ozone layer depletion. This is what kind of questions are possible on the basic level on the concept which we have discussed.